Hi, let's take a look at a real-life use case for Ubiops. In this use case, we will focus on predicting energy consumption. So what we will do, or what we need, is to retrieve energy consumption data from a database. We need to have a model that predicts the energy consumption for the next n hours based on this data. And then afterwards, we need to write the results of this prediction back to the database. Then lastly, we have a Tableau dashboard that reads from the database so that we can plot the predictions next to the historic data. And this entire flow will need to happen every 2 hours. So let me show you how that will work in Ubiops. Due to time constraints, I can't show you every step of the way here. So I've already written a connector that retrieves data from our database and a connector that writes data to our database. And I've already prepared an LSTM network that predicts the energy consumption. What I will show you is the workflow of deploying that LSTM network that I've made to Ubiops and establishing this workflow that retrieves data, performs a prediction, and writes the data back to a database, and how to set up a schedule there. So let's switch to Ubiops then. So this is the Ubiops web app. For now, I will show you how to work with the web app. Everything that I will show can also be done using the client library in Python or in R, or via the command line interface. But this is just the most visual and the easiest to follow. So this is the Ubiops dashboard. Ubiops is built on two concepts, deployments and pipelines. Deployments are pieces of code that need to be hosted and need to be served. So what Ubiops does is when you make a deployment and you push code to that deployment, Ubiops will make a Docker image and scale it using Kubernetes in the background. This way, your code will be transformed into a microservice running in the cloud with its own API endpoint that you can use. So let me show you how I can put my LSTM network that I've made on Ubiops so that it has its own API endpoint and that it's basically a production-ready application. So let's create one. So I go to deployments, click create, and now I need to give some information to Ubiops so that Ubiops can make a correct Docker image and start scaling it. So we need to give it a name. So LSTM network. And I need to provide what input and output fields Ubiops can expect. This can also just be plain data, so unstructured data, but in this case I do have structured data. The input I expect from my network are the past values, so the historic data, which is an array of doubles. I need the amount of predictions that need to be done, so for how many hours my model needs to make a prediction, which is an integer. And I need to know what the last output was, which is a string. So these are the input fields that Ubiops expects. Now I need to define the output fields that Ubiops need to expect from my piece of code. In this case, the main thing is the hourly consumption, which is a double precision. And then I have some other output fields that I just need for inserting it in the right way in my database. So the creation date time, I need the prediction date time, which is also a string. And lastly, I need to know what model version it was. But that's not very important. The main thing is the hourly consume. I can also add some labels so that it can filter my deployments later. So this deployment is a model and it's in the testing phase, basically. So I can add those two labels so that I can check for that later easily. Now I've defined my deployment, and now we can create a version of this deployment, and the version contains the actual code. In this case, I'll just leave the version name as is. It's written in Python 3.8. We also support R, but for now I use Python 3.8, and I need to give Ubiops the code that it needs to run. which is this one. I'll show in a bit what's actually inside this package that I've just uploaded. You can also define some labels on version level, set some advanced parameters. These advanced parameters can often be set on its default, but they are important to know what they actually do. So for one, it's just a memory allocation, which is pretty self-explanatory. And then we have the minimum and maximum number of instances. These have to do with the scaling that Ubiops does in the background. The minimum number of instances is what we can scale back to. In this case, it's at 0, which means that everything will be shut down basically if you don't use your deployment, so that it also doesn't eat up your resources. But this does mean that it introduces a small cold start when you use it for the first time again, because everything will need to be freshly started up, and this introduces some delay. Sometimes you don't want to have this when, for instance, you want to have a deployment that needs to react super quickly because it's behind a web app, for instance, then you can consider changing this to a higher number so that there will always be a few instances available to readily process a request. The maximum number of instances is the other end of this scale. It's what maximum number of instances Ubiops can scale to. And the maximum idle time is after which we start scaling down. Then we also have some monitoring emails. You can add some email addresses here to which monitoring emails will be sent when, for instance, requests have failed, so that you get notified when something breaks, basically. We also have some deployment environment variables. These I won't need for this deployment, but they are very handy when, for instance, you have a deployment that connects to a database. You don't want to hard code your passwords and your credentials inside the code of the deployment, so you can pass them as environment variables and mark them as a secret so that they will be encrypted and will be filtered out all of the logs. But that's it. So I've uploaded my code. Now Ubiops will start building. So what Ubiops is doing in the background is it's making that Docker image. It's performing some minor checks, and it's performing some minor checks. So while Ubiops is building, let me just quickly show you what actually is inside this code that I've uploaded. So this is my code editor of preference, and I will just show you what's actually inside this folder. So this was the folder I had uploaded. And the main thing to note here is this deployment.py. Every deployment package you put on Ubiops needs to have a deployment.py or a deployment.r if you're working in R. And this contains the main instructions for Ubiops, what Ubiops needs to do with your deployment. And in case of Python, it needs to have a class called deployment and at least these two functions, the init function and the request function. The init function gives Ubiops the instructions for the initialization method of the model. Whenever a new instance is spun up, this will be run. So this is handy for the things that need to be kept in main memory, for instance. So that's actually what I'm using here. I have a trained model file, the model.h5 file, which I already load in here with this piece of code. This is to make sure that the model is already ready in main memory. And I also do the same for some transformer I need in my code. Now the request function is the function that Ubiops will call whenever a request is made to your deployment, to the API endpoint of your deployment. And this is where really your chunk of code has to go. So in this case, I'm just transforming the data a little bit and calling the model predict function to actually form my prediction. And afterwards, I push my results back, basically. So in the return statement, you need to have the results or the output fields present that Ubiops expected. So if you remember, I created the output fields creation date time, prediction date time, model version, and hourly consume. This is exactly what Ubiops returns here. And that's what you need to return in the return statement so that Ubiops can handle that properly. But this is where your main piece of code goes. Other than that, there are some other files in this package, and they are quite variable. One that is quite frequently used is the requirements.txt so that we can manage all the dependencies. So in here, you can specify the dependencies of your code, and we will make sure they're properly installed. Any model artifacts or trained model files can go into the folder. And it's possible to add some custom libraries as well, or add something called a Ubiops YAML for specifying dependencies on OS level. Because sometimes when you're developing on Microsoft, you need some specific Microsoft packages, and our instances, our Docker images run on Linux. So sometimes you will need to install some additional things, and you can specify that using a Ubiops YAML, but I won't go into detail for that now. The main thing is to know the deployment.py is what you need, and that's where your piece of code goes. So that's actually what's inside this deployment package. And let's go back to Ubiops then, because our model should be finished. Yes, our deployment finished building, so it's now available. This means that there's now an API endpoint available. You can also get the endpoint URL from the UI here. And requests can be made to this deployment so that this piece of code will process the data, the request data. But I don't want to use this LSTM network on its own. As mentioned before, I want to use it inside this workflow where first I retrieve data, push it to the LSTM network does its work, and then the data, the prediction data out of that will get written away to the database again. So to do that, I need something called pipelines. Pipelines are a way in Ubiops in which you can connect several deployments together to create workflows. These can be sequential, but they don't have to be. So I can show an example, for instance, pipeline. Here, for instance, we have a more like A/B testing pipeline where two models are run in parallel and they both get the same input data, and then afterwards they are compared. But I need a much more basic pipeline. So let me walk you through how I would make one in Ubiops. So let's create one. It needs a name. So energy consumption or energy prediction workflow, that works. And Ubiops needs to know what the input is of this pipeline, what input it can expect. In this case, that's the number of predictions. So for how many hours we want a prediction, basically. And that's an integer. Also for pipelines, we can add some labels, but I won't do that now. And now we can create a version of a pipeline. So just like deployments, pipelines can also have several versions. And also pipelines can have monitoring emails so that you get an email when something breaks. Okay, so now we have an empty pipeline canvas and we can start adding objects here and creating connections. So I need 3 objects. I need, of course, my LSTM network. And I need the connector that retrieves data from the database. I made this one earlier already. This one. And I need a deployment that writes away the data to the database again. I also made this one already earlier. It's called write results. So I've got my 3 objects here, and now I just need to connect them. So the first connection I need is from pipeline start to the data collector, the one that collects the data from our database. And then I need to specify the mapping in Ubiops of how the source, like the input maps to the destination fields that the deployments need. So that's the first connection. Then I can create the second one between the data collector and the LSTM network I have. Also here I need to specify the mapping. And then I need one last connection between the LSTM network and the deployment that writes the result to the database. So there we have our pipeline. And this pipeline now also has its own API endpoint that can be used. So we take care in the background of the data routing and making the APIs of the individual deployments talk to each other so that you can just use one general endpoint for this entire pipeline and use that. So let's just create a request to it. In Ubiops, you can create direct requests or batch requests. Batch requests are asynchronous and can send multiple data points. Direct requests are synchronous and just can send one data point. So let's say I just want a prediction for the next hour. You can create this request right now. What you will see is that because everything is used for the first time, it has a small cold start, and this will take a little bit of time to start everything up. And because of that, processing the request will take a bit longer than when I will do it a second time, because then everything is already up and running. But when this is done, we will be able to see it on this dashboard. So this is a Tableau dashboard we have, in which we show the historic data, so the historic energy consumption data, which is the blue line. And whenever our model has made a prediction, this will be plotted, in this case, in orange on this dashboard as well, so that we can check the predictions in the same dashboard. So this one's still running, and once it's done, we can check the results here, but we should also be able to see it in Tableau. In the meantime, to get an idea of what's actually going on, we can also take a check at the logs. So here you can see everything that Ubiops is doing in the background. And actually, the request is already done. So everything passed in the meantime. And let's take a look at our Tableau dashboard and refresh it. And there we go. There we have our prediction of our model. In this case, just for 1 hour. But if we would have put the input, the n predictions, as a higher number, more points would have been plotted. But we're not entirely done yet. We said that we all wanted this prediction to happen every 2 hours for the next 2 hours. So let's also quickly do that in Ubiops, because requests can be scheduled with use of a request schedule. So let's make one. And say every 2 hours. That's the name, and it's for our pipeline, and the pipeline we have made was the energy prediction workflow. Now, I need this. I need to say for how many hours. So every time it needs to predict for the next 2 hours. So that's why I give 2 here now. And now we can specify the exact schedule. You can do this with the use of the drop-down menu, or when you use the cron expression, you can also type that. I find it a bit easier, so I will just do that. This is every 2 hours. So this cron job expression means that at every 2 hours, at the beginning of that hour, it will send a request to our pipeline. So we can create this one now. And here we have a request schedule, and you can see that it's enabled, and the next run date will be at 4 o'clock. So that's there. And now every 2 hours, our Tableau dashboard will be updated with 2 new expected consumption dots. And that's it. That was a walkthrough of a more realistic use case of Ubiops. I hope it was clear and that you could follow along properly. If you have any questions, of course, don't hesitate to pick up contact with us. You can join our Slack community if you want to chat with us and ask questions about this, and we will happily answer all your questions. So just pick up contact with us and we'll gladly help you out. And I hope to see you the next time.